I think you guys were stuck trying to decide, when do you add, when do you multiply with probability? Did anybody go back and look at that? Okay, so what did you guys come up with? Okay. So what would be an example? So or is adding, and is multiplying. What would be an example when we would take a probability and we'd use that, where we would add? Oh, without looking in the book. Okay, what do you mean by with the card ones? Probability of an ace or a, let's go with a heart. If I was trying to figure out the probability of an ace or a heart, how would I calculate that out? What is the, you said it's going to add, you add in such a way that every card is only counted once. So what's the probability that I would have an ace? Okay, 4 out of the 52. What's the probability that I would have a heart? Do we have anybody that's counted twice? The ace of hearts. So we have to subtract out that ace of hearts, which is one of them out of the 52. So we get 4 plus 13 minus 1, 16 out of 52, and then we would reduce that down to 4/13. Questions there? If we were trying to find the and, if I was looking at the probability that I am going to roll a 2 on a dice and at the same time have the, let's go with draw a heart. So looking at the fact that these are independent events, so we don't have to worry about the drawing a heart given that we just rolled a 2 being a piece of what we have to do. And that is, I guess, a part of this is probability that we draw a heart out of a deck of cards. It would be still that we're given that we roll a 2. Because these are independent events, we don't have to worry about the fact that whether I roll a 2 or not on the dice is not going to change what I draw out of my cards. So this is where we're wanting both things to happen, that we're rolling the dice and drawing a card at the same time, that we want both those things to happen. This is where we get to multiply. What's the probability I'll roll a 2? What's the probability that I will draw a heart? So the probability that both of those things would happen would be 1/24. So when you're seeing the and, that you want both things to happen at the same time, that's when we're going to multiply. Questions there? All right, so that was chapter 4. Chapter 5 was working with our Poisson, was working with our binomial distributions, probability distributions, I guess I should say. Pick a problem out of this one. Is there any good ones that I needed to look at on those? Sure, there's something from this. For some reason, I don't know if these are one of the more commonly missed things. That's the reason why I don't have any of them. Although we did have these as our expected values and our means. Some of the stuff that I thought I remembered being on the final. I didn't grab your guys' final to bring with me, and I should have. Oh, this was finding the probability of exactly so many things. Let's do number 3 on page 241. I don't know why I don't have an example of that one on here. So it starts at the bottom of page 241 and goes on to the top of page 242. So postponing death. Well, I guess we've got to read number 1 first. So if we start off with number 1, wrong button. An interesting theory is that dying people have some ability to postpone their death to survive a major holiday. One study involved the analysis of deaths during the time period spanning from the week before Thanksgiving to the week after Thanksgiving. Assume that n equals 8. Such random deaths are randomly selected from those that occurred during the time period spanning from the week before Thanksgiving to the week after. And also assume that dying people have no ability to postpone death, so the probability that a death occurred the week before Thanksgiving is p equals 0.5, so half the time it's going to be before, half the time will be 1 week after. Construct a table describing the probability distribution where the random variable x is the number of deaths among 8 that occurred the week before Thanksgiving. Express all the probabilities with 3 decimal points. So we have this probability distribution over here, and I'm not even going to worry about going through and finding all of that. So now we have our probability distribution. I want to use that. Well, on number 2, we use that to find the mean and standard deviation for the probability distribution described in exercise 1. Then use those values in the range rule of thumb to identify the range of usual values of the random variable. Is it unusual to find that all 8 deaths occurred the week before Thanksgiving? Why or why not? So if I'm wanting to figure out that, so these we're talking about the probability that 0 deaths happened the week before, 0 out of the 8 deaths occurred the week before. No, this was using, where did I put my little? I had it a little bit ago. This would be sum of the x's times the probability of x. Oops, sorry, you're not seeing what I'm looking at. I think that sounds right, isn't it? No, that doesn't sound right. That's what we're getting ready to do. Find the probability. Oh, this is finding the probability that exactly 0 of them happened that time before, which was using our calculators. As we're finding that probability of exactly, which is what I was getting ready to look at next anyhow. Trying to remember this one. Oh, what is my little thing I'm wanting to use? I'm forgetting something, and I'm not remembering which one it is, where I'm wanting to get it from. NPX. There's, I'm doing the wrong order in the wrong spot. Okay, so finding the probability that was, ooh, that's really close, isn't it? Find the probability that it was exactly 0. You're going into your second distributions. We're going down until we get to the binomial PDF. Then we put in n, then it's p, which is the 0.5, and then it's x, how many you wanted to see. And that's where they're getting that 0.04, or 0.004. I don't remember if that was one of them that we were, I feel like there might have been one that was finding the probability of having exactly a certain amount. But for some reason I didn't write that one down, which is what's surprising me. So I'll have to look. I'll let you know on Monday. That's not scratch paper. This is scratch paper. Do what? Okay. Yeah, we spent some time with that one. So this is fine. The binomial PDF is finding the probability. In this case, it is that we're getting exactly 0 out of the 8 people died on that week before, given that the probability that they die the week before is 1/2. And so then you could go through and do that the same thing for all of them, doing now for they were exactly 1 day, or exactly 1 person dying that week before. So given this table, now that we have that, find the mean and standard deviation for the probability distribution. So how would I go about finding my mean? We've got 2 options. One option is you can go about doing it by hand, where you're putting in your x's times the probability that x happens and adding all those together to find it. So I would take the 0 times 0.004 plus the 1 times 0.031 plus the 2 times the 0.109 and go through each of those. Or this is where we put things into our calculator, where we could put in the values. Oops, there's no 9. Putting in the probabilities. And then if I'm trying to find the mean and the standard deviation of those together, this is when we're going into stats. calculate, and you're doing your one variable statistics, but if you don't tell it where to go, it just does list 1. This is when you do list 1, comma, list 2. And it gives you the mean and the standard deviation. So that's when you're doing that, when you've got the values and then the frequencies, or in this case the probabilities that those were happening, that it puts those two pieces together. List 2. So you should be getting the mean to be 4 and the standard deviation to be 1.4. Now, part 3 is the one I was actually trying to get to. Exercise 1 involves 8 randomly selected deaths during the time period spanning from the week before Thanksgiving to the week after Thanksgiving. Assume now that 20 deaths are randomly selected from that time period. Find the probability that exactly 14 of the deaths occur during the week before Thanksgiving. So if I'm wanting to find the probability that exactly 14 out of the 20 deaths happen the week before Thanksgiving, what would I go about doing? Okay, I'm going to go back to that binomial PDF. So second vars, going up to the binomial PDF. N is 20. P is, and X is. So we get our probability to be the 0.037. Questions? Now, the next question is it unusual to have exactly 14 deaths occur the week before Thanksgiving? Why not? So it's lower than 0.05. Is that usual? This is unusual. Okay, so it's unusual to have 14 out of 20 deaths happen the week before Thanksgiving. So if you're going to have 20 deaths in that time span of 2 weeks, it'd be strange that 14 of them happen during the first week and only 6 of them happen the second week. That would be unusual. If the probability of exactly 14 deaths is very small, does that imply that 14 is an unusually high number of deaths occurring the week before Thanksgiving? Now, this is the probability of exactly 14. Is that the piece that I'm wanting to really focus on? What else do I need to consider? So it is unusual to have exactly 14 deaths happen the week before. But am I only going to worry about, if I'm trying to see if there were 14 people that died, what else should I think about when I'm trying to compare probabilities to decide things? Probability of 15 deaths, 16 deaths, 17, 18, 19, 20. And I have to add, because this is just the probability that it's exactly 14, not 14 or more deaths. So to really decide if this is very unlikely that it could occur by chance, we need to think about what's happening with the 14, 15, 16, 17, 18, and 19. And 20. Yeah. That one's not going to be on the test. That one I know. Now, I might, this is kind of what I was thinking I was looking at on this problem. Actually, I don't even think I gave you this one. If I was asking you for the probability that was, 14, or in this case, if I was just doing the x's being from 0 to 8, probability that there was, 7 or more deaths out of 8, then we would just find the probability of 7, exactly 7, plus the probability of exactly 8, and we would just add those two numbers together. I don't even think that's on there, though, if I can remember right. All right, so then Chapter 6 started with working with our normal distribution. So on page 320, number 7 is one of them that is similar to what is on the test. And this is one of those similar to what's on the test and also similar to one that's similar to one that's frequently missed on the test. So that's the ones I wrote down were the ones that were the most commonly missed. There are 40 questions on the test. Have I told you guys that part already? Okay. 40 questions, all of them are multiple choice. So basically each one is 5 points when it goes to calculating out how much it's worth on the test. When I go to replace things, it's the percent that I use. The percent from your final is what gets used to be able to be your replacement. All right, so number 7, high cholesterol levels. The serum cholesterol levels in men ages 18 to 24 are normally distributed with a mean of 178.1 and a standard deviation of 40.7. Units are milligrams per 100 milliliters, and the data are based on the National Health Survey. If one man ages 18 to 24 is randomly selected, find the probability that his serum cholesterol level is greater than 260, a value considered to be moderately high. I'm just going to do it over here. I don't feel like walking back and forth to the board. So if I'm wanting to find the probability that his level is greater than 260, I know that the mean, so the population mean is the 178.1, the standard deviation is the 40.7. What do I do? Second bars, normal PDF, and then what? Okay. Okay, what are we going to put in? Not just your x value, but you've got to put your lower bound and your upper bound. So if I'm wanting to test the mean is greater than 260, then we got to put in the lower bound, which is the 260, our upper bound, which we'll just pick some really, really, really big number. The mean, which is the 178.1, the standard deviation, which is the 40.7. Oh, I thought that was right. Oh, I don't do PDF, I do CDF. It's the cumulative. That's why it didn't work right. And that's why yours didn't ask it right. Because now you need to use the cumulative or normal CDF. So you've got your left because it's the cumulative. You're going to want to each time. Because we're doing the cumulative, trying to figure out what that range of value is instead of figuring out what it is for one exact value. I don't think we've used the PDF on anything. Not the normal PDF at least. That, I think, is used to give you what's on the tables. If you're wanting that exact value that was on the table, I think that's what it's used on. Now, had I forgotten which button to hit and it wasn't working, I need a backup plan. And the backup plan is I've got the formulas on the reference sheet. What'd you say? Phone a friend is not an option. So, we're looking at things that are normally distributed. I'm not looking at. I need to figure out if I want the probability that x is greater than 260, I need to change this into the probability that z is greater than some value. So to figure out what my z-score is, and I know I'm using a standard score because I know the population mean, the population standard deviation, and I'm trying to convert that x value that I have. So it's x minus the population mean, so it's at 260. Maybe I should write on the board because I can't see everything at once. 260 minus the 178.1 divided by the 40.7. which gives me 2.012. Now that I have my z-score, so I want you to know that z is greater than 2.012. This is telling me I have a nice normal distribution now. I want the probability that if my z-score is the 2.012, that it's going to be greater than that. Oops, you can't see my little chart. If I looked at my table, my z-score is 2.012, so 2.01 on my table is the 0.9778. How do I find this is the probability that's to the left. I want the probability that's to the right, so we do what? Okay, 1 minus the 0.9778, which gives me the same answer we had before, which is the 0.0222. So same thing. Well, I guess the calculator gave us 0.0221 instead of 0.0222. That same idea. Now, on the final, I am not going to try to trick you with giving you things like 0.0222 and 0.0221. If you're using the tables and you get 0.0222 and you use the calculator and get 0.0221, I'm going to have one of those two numbers on there. I can't tell you for sure on different ones which one I use, if I use the table or if I use the calculator. But it's going to be the only one that's going to be 0.022 something. The other answers, now I might have the 0.9778 will probably be one of them I'll have listed, where it just comes from the table and you just forget to subtract it from 1. But you're not going to have the rounding being an issue. Also, the rounding rules that we've used will not be a part of things that you have to pay attention to for the final. So I will not have, like if you're trying to find the mean ages, and the mean age comes out to being, if you use your calculator and you get something like 20.5684 as the mean age, I'm not going to have things like, well, it's 21 or 21.6 or 21.57 to where you have to know how many places to round this. If it's ages, we've been rounding all of our ages to whole numbers was probably what was given. You should round it to 20.6. But I will have all of them rounded to 1 decimal if that's the case. So it's not going to be a case where some of them are rounded to 1 decimal and some of them are rounded to 2 decimals, and that's the part to pay attention to. So the rounding rules are not going to be an issue. So don't even start stressing on any of those. Questions on this kind of problem? Yes. Yes, last test we'll have some problems on there also. If we looked at part B on number 7, if one man, ages 18 to 24, is randomly selected, find the probability that his serum cholesterol level is between 170 and 200. How does that change? If I want the probability that he's between 170 and 200, so you're going to go to your second vars, you're going to do your normal CDF, and you're going to put in your lower at 170, your upper at 200, your mean is still the 178.1, and the standard deviation is the 40.7. So that's going to give you that probability that it's between those two of being that 0.2837. Oh, nope, I rounded wrong, sorry, 0.2836. Now you could have gone through and done it by hand where you found the probability that it's less than the 200 minus the probability that it's less than 170. So if you were doing it by hand, this is when you would find the probability that your x value is less than the 200 minus the probability your x is less than 170. You would have to convert those both to z-scores and use your table to figure that out. So it's very similar to what we just did a second ago. Only get to do it for 2 of them instead of just 1. Now, part C on this one says if 9 men ages 18 to 24 are randomly selected, find the probability that their mean serum cholesterol level is between 170 and 200. That's where we had to change our standard deviation. That one is not on the final. So on the final, it will only be for a group of one, or an individual, versus putting them in groups. On this particular problem, yes. Now, there's other times I might give you data and tell you to find me the mean and standard deviation. Which, how do you do that? Put it in my calculator, so I'm going to go into Stat, Edit, and let's just do the 1 through 8 that I already had in my list one. So if that was the case, how would I find the mean and the standard deviation of that list? Okay, Stat, Calculate, and it's that one variable statistics. And if it's just that first list, you just hit Enter. A little bit ago, we did list 1, comma list 2, when that list 2 was the frequency things were happening at. Yep. Yeah, your frequency list just keeps coming up weird times. No, you're probably not. Okay. If you have, anytime you have a frequency list on yours and it's been messing you up, go to list 2 and just turn all of these into ones so that you have as many ones as you have numbers on the other side. Then you can go with that on the final, because you won't ever have 3 lists that I'll make you put in at the same time. And so then you could just make list 3 your frequency list. I don't know why it won't let you get rid of that. I was going to say, we've done something that brought it in, and I don't know how to get rid of it. And I haven't played with those calculators enough to figure that out. All I've done is figure out a workaround, which is to put your ones in there. I'm sure there's a way to do it if I researched.
So if I ever have a frequency, just go ahead and make sure it's selected at all.
And it'll work. Mm-hmm. Okay, other questions on that one? Let's look at Part D on that one. The Providence Health Maintenance Organization wants to establish a criterion for recommending dietary changes if cholesterol levels are in the top 3%. What is the cutoff for men ages 18 to 24? So now I'm looking for the opposite. I know I have a normal distribution. I want to cut off this top 3%. That's a 3 there. If I want to cut off the top 3%, how do I find this X value that separates the top 3% from the lower 97%? Okay, and do what? Okay, look at my table for the 0.97, and I'm looking at my z-scores because this is a normal distribution. The closest we get to 0.97 is the 0.9699, which is what? Which is your 1.88. Is everybody okay with that? So this is telling me my z is 1.88. Is that the cutoff score? Okay, now we have to convert it back into an x value. And so that's using that same formula we had before, that z is x minus the mean over the standard deviation. So there is a calculator shortcut for that. So this was the nice, simple little algebra equation that I made you guys actually have to be able to solve. And so we could solve it from there. But what was our calculator shortcut? It was your inverse norm. Oops, hit the wrong button. So go into the second vars, and we're doing our inverse of our normal distribution because you're undoing that normal distribution now. You're going in the reverse. What do you put in first? Okay, put in the 0.03. mean, and then your standard deviation. So that gets me my cutoff score. Oh, hey, you know what? I just did that backwards. Always do your area to the left. I was thinking that's a really strange number that I didn't think sounded right. I knew my cutoff score had to be above my mean, and my mean was at 178, so I knew I was having issues. Just had to figure out what that problem was. So always do your area to the left, which is the 0.97. Then do your mean, then do your standard deviation. Now, some of these problems, hopefully you've gotten enough common sense going on with statistics now that some of these answers you can just eliminate by common sense being a part of the issue. For this example, getting my answer of 101, my common sense was having issues with it because if I'm wanting to cut off the top 3%, it's not going to be smaller than the mean score. So if the mean is 178, I know it's got to be bigger than 178. And so that kind of eliminates some of those answers that just don't make any common sense. Crap, it's already time to go. All right, Monday I'll try to go through things a little faster. Since I threw in a couple problems that weren't on my list, it really threw me off. So Monday I'll go over, I've got about 5 more questions I want to make sure we spend some time looking at that are some of the commonly missed ones, and then I'll have our test to be able to look at. Nope. You'll get to look at them in class. Yeah. You guys are just shooting for all kinds of possibilities, aren't you?